So we didn't quite have enough time in class this week to look at some of the more involved trig limits, and so I wanted to record a couple more examples to post and share with you. At the very end of class on Tuesday or Wednesday, we looked at the limit as x approaches 0 of sine x over x and showed that that is equal to 1. That's actually a really powerful tool for addressing lots of other identities involving trig functions, and not just sine. So let's look at sort of the first most fundamental example, and this is where we take the limit as x approaches 0 of sine of 8x over 5x, something like this. So this is really close to what we have, but we've got an 8x and a 5x, and those don't quite agree. So let's take a look here and think about what happens with the limit of sine of 8x over 8x as x approaches 0. Well, as x approaches 0, 8x also approaches 0, so really the limit of this has to be equal to the limit as y goes to 0 of sine y over y, or 1. So we can basically do a substitution, but we've got to have 8x over 8x, as we'll, sine of 8x over 8x, as we'll see here. So how do we get that? Well, let's put an 8 in the denominator if that's what we need. And to do that, we're going to have to throw an 8 in the numerator as well, so that we cancel out, they're still equal. It's just like the rationalizing the numerator or rationalizing the denominator trick we looked at. And now we look at this, and our limit laws say we can pull out that 8/5, and now we've got the limit as x goes to 0 of sine of 8x over 8x, which we just argued is 1, so the whole limit there is just 8/5. That's a pretty standard strategy, so let's look at something a little more complicated. Let's take the limit as t goes to 0 of the tangent of 5t over sine of 3t. Well, we know about limits involving sine, so let's rewrite tangent in terms of sine and cosine. We have the limit as t goes to 0 of sine of 5t over cosine of 5t times 1 over sine of 3t. And I broke it out like this because we're going to want to introduce a few extra things. So we know what to do with the limit of as t goes to 0 of sine of 5t over 5t. But before we get to that, let me point out that cosine of 5t, t goes to 0, that goes to 1. So that middle factor, the limit exists. So we really just need to figure out what to do with the sine factors. So now let's start adding in some extra bits. We want limit of sine 5t over 5t. So let's slap in that factor of 5 in the numerator. We put the t in the denominator, so we need another t in the numerator. Well, maybe let's put it with the sine of 3t, and let's actually make 3t in the numerator there. And so we need to put a 3 in the denominator. If you take a look at what's that limit right now and you cancel everything, it really is what we had a moment ago. Okay, so now what about this limit of 3t over sine of 3t as t goes to 0? Well, this is the limit as t goes to 0 of 1 over sine of 3t over 3t. And aha! We know that the limit of the denominator there exists, and it's 1, right? By the same reason when we had 8t, factor of 8 in there in the previous example. So now the limit laws say this is the limit of the numerator divided by the limit of the denominator, since the denominator's limit isn't 0. And so that limit is just 1. Okay, so the limit of the last term is 1, the limit of the first term is 1, and the limit of the middle term is, middle factor is 5/3. So all the limits exist, so we can split it up into 3 limits, just like this. And notice that the first limit is 1, the middle limit is 5/3, and the last limit is 1, so the whole thing is 5/3. For a final example, I want to do an example that's in the book just to illustrate another important principle, and this is to look at the limit as theta goes to 0 of cosine of theta minus 1 divided by theta. So this is a 0 over 0 type thing because we want to look and see can we substitute in, but the denominator would go to 0. Cosine theta is theta goes to 0, cosine theta goes to 1, so cosine theta minus 1 goes to 0. So we've got 0 over 0. Now, we've seen this rationalizing trick. It really is more of a difference of squares trick or strategy, right? So if we think about cosine, we can multiply the numerator and denominator here by cosine theta plus 1, because then when we do that, we wind up with a numerator of cosine squared theta minus 1 using the difference of squares, and the denominator, we'll just keep it as cosine of, or theta times cosine of theta plus 1. So what about that cosine squared theta minus 1? Well, remember the trig identity, sine squared theta plus cosine squared theta equals 1, so we can rewrite that as cosine squared theta minus 1 equals minus sine squared theta. So let's plop that into the numerator. And get the limit as theta goes to 0, minus sine squared theta over theta times cosine theta plus 1. Now, we've got a sine theta over theta minus sine that we'll pull out front. And so let's take a look at it, writing it that way. Okay, so we've got two factors inside the limit. Sine theta over theta, that limit exists and goes to 1. Theta equals 0 is in the domain of sine theta over cosine theta plus 1, right? The denominator is 2, the numerator is 0. So but the limits of both factors exist, so we use our limit laws. And we get that this is, keep the minus sign out front, limit as theta goes to 0 of sine theta over theta times limit as theta goes to 0 of sine theta over cosine theta plus 1. And again, those limits are 1 and 0, so the whole limit is 0. So this is another limit that we're going to see a couple times and might be useful, but the strategies involved are important as well.